All right, so I'm going to do 32 first. One angle is measured as 25 degrees, the other is 40. Okay, so we have this picture. Looks like this side is 25 degrees and this side is 40. Then it says if the observers are 100 feet apart and the helicopter lies over the line joining them, how high is the helicopter? So it actually wants that distance there. Okay. And so what I would do is first I would find my two side lengths, and then we know this is going to be a right angle, and so then we can use regular trig to find the height. And actually, now that I think about it, we only need to find one of these sides in order to find the height. So first things first, we're going to do 180 minus 25 minus 40. Okay, so that's 180 minus 65, which is 115 degrees. So this is 115 degrees up here. And then we're going to do sine of 115 over 100 equals sine of, let's do 25 over, let's call it little a. So then we have a sine of 115 equals 100 sine of 25. And we would do 100 sine of 25, which gives us that. And then remember, we have to divide by sine of 115. This is that. So 46.6 is the height of our helicopter. So this length here is 46.6. Okay, I'm sorry, the distance from this side. So now that we have that, we can find our rectangle, or a triangle height here, how high it is, using regular trig. So we know that this is opposite, and we know this is now our hypotenuse. So we have sine. So then I would do sine of 40 equals opposite over my hypotenuse, which is 46.6. So 46.6 sine of 40 results in 29.95. So it's 29.95 feet. In the air. Okay? So this is one of those doubles that you have to do to find that height. So anytime you see two triangles, you're usually going to have to use law of sines or law of cosines once, and then a second time you're going to have to use regular trig. Okay, which was similar to, I think it was example 2 in the notes that we did. It was either 2 or, example 2 it was in our notes. Okay? So 11, it says A is 3, C is 1, B is 100. So I'm going to draw this picture. I have big A, which across from big A is 3. Big C, which across from big C is 1. And then big B is 100. Okay? So what we're going to do is we would do law of cosines here. And the reason we know it's law of cosines is we don't know the side across from the 100. Okay? So I would do C squared, actually no, it would be B squared, equals little a squared is 3, C squared is 1, minus 2 times 3 times 1, cosine of 100. Okay, so I'd type this side in. So I get 3 squared plus 1 squared minus 3 times, minus 2 times 3 times 1 cosine of 100. Gives us this, so 11.04. So b squared equals 11.04, and then I would square root each side. And can get 3.323. So this side is 3.323. And now that I know that side, I can use trig, regular trig, or not regular trig, law of sines to find my other one. So I'm going to do sine of 100 over 3.23 equals sine of A over 3. So from that, I'm going to get 3 sine of 100. Close my parentheses, and I'm going to divide it by that previous answer, it looks like. So I get 0.8891, and then I have to do sine inverse on that to get 62.8 degrees. So this angle would be 62.8. Okay, so what I did is I cross multiplied, got 3 sine of 100 equals 3.323 sine of A. Immediately I divided because I knew that if I hit enter on this other side, I want to get the right numbers. So I get sine of A equaled that 0.8 something, and then I did sine inverse on each side to find what angle A was. Okay, so now that I have angle A, I would do 180 minus 100 minus, I'm going to use that answer button again just because I can. And so this other angle is 17.2 degrees. So this angle would be 17.2 degrees. And there you have it. You have your two angles that you're missing